So hello people, in this video we'll be talking about the contest February Cook of 2023, and I was able to solve the first two problems. So it is the editorial of the first two problems. The first two problems were pretty good and they had some observations, and let's look into it. The first problem is that take not less. In this problem, the problem says that we have some like n piles of stones and every pile has ai stones. Now the first player will go and choose some number of stones from a pile, and now the next player has to choose the number of stones that is strictly like not strictly but greater than or equals to the number of stones that previous person chose. And if some person is not able to choose that many stones, then we can say the game will end and the other player will win. Now how can we solve this problem? If we just look into it carefully, we can claim that if the number of stones, the maximum number of stones in a pile are like only one pile has maximum number of stones, then Alice will for sure win. Suppose the pile looks like the n piles look like something like this. Like in this problem, like if this is the array, then we can say that Alice will choose the pile with 8 stones, and now the Bob will have to choose the pile with like like from a pile number of stones that is greater than or equals to 8. But as now there is no other pile that is having number of stones greater than or equals to 8, so Alice will win in this case. Now let's suppose there were two number of like the count of 8 was 2, then what would have been the result? So again, the Alice would have said that to win Alice will take the number of stones that is equals to 4. Why 4? We'll look into it in a moment. And Bob will choose the number of stones. How much will it be? It will be greater than 4. So let's suppose he again chooses 4 from this second pile, which is of 8. Now Alice will say that I will choose a total number of 8 stones from the first pile. Now Bob won't have any move and Alice will win. So if we just look at the observations, so what I can say is if the frequency of every AI in this array is an even number, then Alice can't win. But if the frequency of any number is odd, then Alice can win. The logic behind that is, let's suppose the array was 8 8 4 4 and 2 2. Now let's look how Alice can't even win. So in this case, if Alice chooses a 2, let's suppose, then Bob will counter it with a 2, right? Now if Alice chooses let's suppose 4, then Bob will counter it with a 4, and Bob will take exactly the number that Alice takes. And in this way, because we have even number of terms, like every number has even frequency, so when Alice will take the maximum number, let's suppose 8, so then Bob will also have an option of taking the maximum number 8. Or maybe even if Alice takes a number 7, Bob also will have an option of taking the number 7. In this way, Bob will not let Alice win. So the conclusion of the problem would be that Bob will win. But if we look something like, if we have any frequency as only an odd number of frequency of some element, then the game would go like, now Alice has a strategy to win. Now if Alice chooses a 2, now Bob will have no other option than to choose something like a 4 or maybe a 3. But if Alice chooses a 2, suppose, then the game would become like this, with just Bob starting first. Now if Bob start first and every element has a frequency of even numbers, then I can say that the other person will win. Then Alice won't let the Bob win. So in this way, the Alice can convert it into a game that was like previous one, when every element has an even frequency, and in this way the Alice can win, otherwise the Bob will win. So idea is, we'll count the frequency of every element, and if every element has a frequency that is even, if every element has even frequency, then Bob will wins, else Alice will win. So let's look how can we implement it in the code. The code for it is, we'll take an input n, and we'll take a vector which will be vn, and we'll count the frequency of every AI with the help of a hash map, and we'll iterate over the vector. We'll take the inputs and I will do the count I plus plus, and in the next loop I will check whether the frequency of any number is not equals to 0, which means like modulus 2 is not equals to 0, which means the frequency of any number is odd, then I can just say that Margaricha would win, Maricha, like whatever it said, and otherwise Zainak would win. So that's the logic for this problem. Let's go to the next problem. Okay, the next problem is Alice Potter and Dumbledore. So let's look into the second problem, which is Alice Potter and the Dumbledore army. So in this problem, there are n members in the Dumbledore's army, and there are m sessions that are going to take place. In every session, there is some training given to a participant, and we have to find the answer of, for each session we have to find answer 1i, like I1 plus answer I2 plus answer I3 till answer II. So the answer I1 means, for giving a training, total one training, how much time do we need? And basically, for the answer I2 means, to give a total of two trainings, how much time do we need? Similarly, answer II means, for giving a training of, like for giving I trainings, how much time do we need? So let's look into this example and it will be more clear. So let's just look at here. So currently, initially what we had is, we had initially we are giving training to participant number 5, and participant number is 5. 5 is given a training of time 1. So for the first session, we will print the amount of time taken to give one training, and initially as only 5 is getting a training, so it will take one time. So for giving a training, total of one training will take one time. So the next time we are having a participant number 3 given a training of time 2. So now we have two trainings, so we have to calculate the time taken for given a training of, like to give a training to one, like one training, and the time taken to give two trainings, the sum of those. So basically, what would be the sum? So for giving one training, this 5 can take one training, and it will take how much time? It will take one time. So the answer of this row would be the answer here. Now what we see here is, the next time for giving training to two people, he will need at least two time, because the 3 takes 2 time, and in 2 time 2 people will get trained, like 2 trainings can be given in the time total of 2. So the answer would be 1 plus 2, that is 3. The next time 5, the participant number 5 again gets a training which is of time 2. Now if we just again calculate, what we can see here is, for getting a training of 1, it can be done in 1 minute, that as 5 can take a training of 1, and for taking two trainings it will take at least a time of 2, because in 2 time, uh, 5 and 3 can take trainings. 5 can get his training over in time 1, and in 2 time 3 also can get his training over. So we get two people, like two trainings done in a maximum of 2 minutes, like minimum 2 minutes we can get two trainings done. And now to again we have to find, as it is the session number 3, we have to find the number of time taken to get done with the 3 trainings. Now we can say that for all of these trainings to happen, we'll need a time of 3, because 3 is the maximum, because 5 will take one time to complete one training, and 5 will take a total of 3 time to complete two trainings, and this 3 will take a time of 2 to complete one training. So in total the maximum number of time that will take is 3. In the time 3, both of, like all the 3 trainings can be completed. A person, participant 1, and he will get a training of, which will take a time of 2. So again we'll have to compute that what will be the total time for giving one training, plus total time for giving two trainings, plus total time for giving three training, plus total time for giving four trainings. So for this it would be 1 only, because 5 can take a training in only time 1, and then this would be 2 again. Why? Because in a time of 2, the both the people 5 3, or maybe 3 1, or maybe 5 1, or we can say that all the 3 people can take the training. So we can give 3 trainings in time 2, and even for giving 2 trainings we will take a time of 2 only. So that's why we can say that it will take a time of 2 to give 2 trainings, like 3 trainings. Namely, we can train 5 3 and 1, because 5 for its first training will require time 1, for 3 will require time 2, and 1 will require time 2. So the maximum time is 2. We can say that will require a time of 2 to train these 3 people. Now again, to train 4 people, what would it be? So to train 4 people, because 5 takes a maximum time of like not 2 people but to give 2 trainings, so 5 takes a time of 3. So that is the maximum currently. So it will take 3 time to train all 4 people. So the idea generally is the maximum of every number, like currently the maximum for 5 is 3, the maximum for 3 is, sorry, the maximum for 3 is 2, and maximum for 1 is again 2. So we'll take a maximum of time 3 to train all the people. Now how can we generalize it? So if we just try to observe a pattern, we can say that, so if we try to observe the pattern, what we can say is that if any number comes, we can generalize it like that. Now you have to do a careful observation. So if any numbers comes, let's suppose here comes a 4, and it has a value that is equals to, let's suppose let's take a big number that is 10. Now we can say that for completing all of these tasks, we will need at least a 10. So for completing the fifth task, it must be 10. And for completing the 4 tasks, it cannot be less than 3. It cannot be less than 2, it cannot be less than 2, it cannot be less than 1. So here we can fill 2, 2, 2, 3. But what if suppose for 4 it was, let's say, a 1. Now what can we observe is this one task will be able to do it in 1 only. This 2 will be able to do it in how much? We will be able to do 2 tasks in the time 1. Why? Because we can do the 5th and the 4th task. Now again, how much time will it take to do 3 tasks? So it will take a time of 2. If for 4 tasks, it will again take a time of 2. And for doing 5 tasks, it will take a time of 3. So this one just got inserted in its correct position. And that's the logic that we have to use. Now we can say that if any number, like if some number something else occurs, like if we have some, again we got a 5 with a number, let's say again a 12. So as we know that we had 5, 1, 2, and the 12 comes again. So how much a total it will take? The 5 will take a total time of 15. That is 15. So now we can be sure that the 6th task cannot be done in less than 15. But we can be sure that these tasks can be done in their respective time only. So it is just that we have to add the time for the last element that we inserted, and that is it. It will work. So that is the whole logic of this problem, and let's see how can we code it. So if we just check this problem, we can see that we take the two inputs n and m. We take a vector of size n plus 1 which will basically store the count of current total, like the count of total for the current element. Like here in this problem you can see that the count of 5 was totally a 15, not the count but the total sum of times is 15. So we can take a 15. So if we just take the inputs, then we can say that a for loop will run from 0 to m, and we'll take the two inputs a and b, and for every a we can add a total time of b to it, and after that we can add to our answer the element va, and after that we can just print the answer for every session right there, and this will work. So I guess these were the two solutions that I was able to come up with, and thank you for watching.